This video lesson is about the three-dimensional coordinate system. This coordinate system is also called as the rectangular coordinate system. This lesson will be divided into 4 parts. The first part is about the three-dimensional coordinate system itself. The second part will be about the distance formula and the midpoint formula and how we can use them. The third part and the fourth part is about the basic objects in a three-dimensional space, which are spheres, planes, cylinders, and traces. First, let us recall that the set R of real numbers is usually represented by a straight line. This straight line is oriented in such a way that there is always a positive direction and a negative direction. This line is also called as the real number line. Then, we talk about the set R2, which consists of all ordered pairs x and y, where x and y are both real numbers. We have learned that this set is usually represented by a flat plane, also known as the Cartesian plane. Every point in this plane will be represented by an ordered pair of real numbers. A natural extension would be the set R3, consisting of all tripoles, ordered tripoles of elements x, y, and z, where x, y, and z are all real numbers. Of course, a natural question would be, what does R3 represent geometrically? The answer to that question is the three-dimensional space that we are living in. In this space, we have the notion of length, width, and height, all at the same time. To associate the set R3 with the three-dimensional space, we will start by choosing or selecting a point in space and label it as 0, 0, 0. This point will be called as the origin. Next, we draw 3 mutually perpendicular number lines through the origin. Call these lines as the x-axis, y-axis, and z-axis. These lines being number lines, they are oriented in such a way that there is always a positive direction and there is always a negative direction. By convention, the arrowhead in this diagram indicates the positive direction. So, if this is the positive direction of x, the other direction should be the negative direction. We then label the points in the line as usual, as they are real number lines. This is the coordinate 1 in the x-axis, this is the coordinate 2 in the y-axis, this is the coordinate 3 in the z-axis. Now this arrangement of things in R3 is what we call as the right hand rule. For the right hand rule, the x-axis always points towards us. The y-axis points towards our right hand, while the z-axis always points upward. There is another convention though, also known as the left hand rule, where the position of x and y are swapped. So for example, in the left hand rule, the x-coordinate, the x-axis will be here, while the y-axis will be here. But for our purpose, we will stick with the right hand rule. Now, the unique plane that contains both the x and y axis is what we call as the xy plane. In the diagram, it is shaded as blue. Similarly, The unique plane that contains both the x and z axis is called as the xz plane. In the diagram, it is given by the pink plane. And the unique plane that contains both the y and z axis is what we call as the yz plane. In the diagram, it is represented by the green plane. These planes are also called as the coordinate planes in a three-dimensional space. Now, to associate every point in R3 with a point in space, the ordered tripole ABC will correspond to the unique point P in space such that the following holds. Number 1, the directed distance of P from the directed distance of P from the YZ plane, where this is the YZ plane, and this is the point P, so the directed distance should be the coordinate A, so this length should be A units. So let us write A here. On the next, the directed distance of P from the XZ plane, as shown, must be the coordinate B, or must be the number B. Then the directed distance of P from the XY plane should be the number C. So the ordered tripole ABC will be represented by P. As you can see, you can draw a rectangular box so that the line segment over here is congruent to the line segment over here. So if this is A units, this should be A units. That's why this should be the x coordinate A. Similarly, this should be the y coordinate B, and this should be the z coordinate C. The ordered tripole ABC is what we call as the coordinate of the point P in singular form. But we also say that A, B, and C are coordinates of P. However, we should be careful about the order in which we say the coordinates, because the order here is important. Interchanging two elements in this collection will give you another meaning. The points in the x-axis have coordinates of the form x0, 0 because 0 ang y coordinate niya at ang z coordinate ay 0, at ang directed distance niya from the yz plane is x. In a similar fashion, this is wrong. There's a correction. The points in the y-axis must have coordinates of the form 0, y, 0. Again, this is wrong. The points in the z-axis have coordinates of the form 0, 0, z. The points in the xy plane have coordinates xy, 0. Here, the z coordinates are all 0. The points in the xz plane must have coordinates of the form x, 0, z. Here, the y coordinates are all 0. The points in the yz plane must have coordinates of the form 0, y, z. Here, the x coordinates are all 0. These coordinate planes separate it separates the space into 8 octants. Ang tawag natin doon sa 8 bahagi ng space na binibigay ng tatlong coordinate planes, na pinoproduce ng tatlong coordinate planes ay mga octants. Analogously sa two-dimensional space, yung dalawang coordinate lines or yung x at y axis, hinahati yung plane sa 4 na bahagi, kaya tinatawag ng quadrants. In this case, The coordinate planes divide the space into 8 parts. That's why we call them the 8 octants. The first octant being the one whose points have all positive coordinates. So, usually, yung camera natin, nilalagay natin dito sa first octant. So, yung nakikita nyong bahagi ng space ay yung first octant kasi ito yung positive na direction ni X, positive na direction ni Y, and positive na direction ni Z. So, yung bahagi ng space na nandito sa portion na ito is what we call as the first octant. This manner of assigning coordinates to space is what we call as the three-dimensional coordinate system, or the one-to-one correspondence between the set R3 and the three-dimensional space is called as a three-dimensional coordinate system. So let's have an example. Suppose we are asked to sketch the line segment whose endpoints are P and Q with the following coordinates. P being 3, 1, 2, and Q being 1, negative 3, negative 2. In order to do this, we first need to decide which part of space will be shown. To decide on this, you have to look at the given x coordinates. So in this case, the x coordinates ranges from 1 up to 3. So there is no need to show the negative side or the negative direction of x. So the x-axis is sketched as shown. Right? For the y-coordinates, the range of values to be considered will be from negative 3 up to 1. So we have to consider some of the negative values of y and some of the positive values of y. That's why the y-axis is sketched as shown. Lastly, the z-coordinates involved are negative 2 and 2. So we have to include the range from minus 2 to 2 in our sketch of the z-axis. That's why the z-axis is sketched like this. This is the negative side, this is the positive side. Next, we label, here we show the xy plane for us to have a better visual understanding of the situation. The next step is to label the important points. For example, the x-coordinates 1 and 3 are marked as shown. The y-coordinates negative 3 and 1 are marked as shown. And the z-coordinates negative 2 and 2 are also marked as shown. Take note that for the markings, you have to make the markings parallel to the given axis. So to sketch the point P or to locate the point P, we first look at the x and y coordinates, which are 3, 1. What we're going to do is in the xy plane, we locate the point 3, 1 as shown. So in this case, this is 3, this is 1, so the point 3, 1 will be located somewhere here. In fact, this point is the point 3, 1, 0 because the z-coordinate in this plane is 0. Next, because the z-coordinate is 2, see, we have to create a copy of this rectangle 2 units above the xy plane, shown. And then, we draw the vertical pillars connecting corresponding points. Now, the vertex opposite the origin in this rectangular box should be the point P. Okay? Now, to sketch the point Q, we will do the same. First, in the xy plane, we should locate the point 1, negative 3. 1, negative 3 can be located as shown. This is 1, this is 3. So 1, negative 3 can be represented by drawing this rectangle. Do you see that? So at this moment, this is the point 1, negative 3, 0. But notice that the z-coordinate is negative 2. Therefore, you have to go down 2 units below the xy plane. So we have to make a copy of this rectangle 2 units below the xy plane. So we have this rectangle. And then again, drawing the vertical line segments connecting corresponding points, we have the following rectangular box. Again, the point opposite the origin in this rectangular box is the point Q. Now we are asked to sketch the line segment from P to Q. So we just draw a straight line segment from P to Q. Now you see the broken part of the line segment is illustrated as shown to indicate that we don't actually see it from above because it is below the xy plane. Now sometimes you may want to change the viewing angle so to see the object clearly. For example, if I change here, my eye is the camera, right? So if I move the camera over there, we shall see something like this. So they are the same but different angle. Okay, let us now talk about the distance formula. In the Cartesian plane, the distance between the points P1 and P2 with the given coordinates are as shown. We subtract the x coordinates, then take the square. We subtract the y coordinates and then take the square. We add all of these squares, then finally take the square root. A natural extension for the space R3 should be to include the z coordinates as well. So what we do is we subtract the x coordinates, then take the square, subtract the y coordinates, and then take the square. Additionally, we are now going to add the square of the difference between the z coordinates. Then the resulting sum, we will take the square root of the resulting sum to get the distance. For our purpose, we shall be writing the distance between P1 and P2 using this notation. It's like using the absolute value, but it's not. Well, to justify why this is the case, if these are the points P1 and P2 in the formula, no? To get their distance, what we are actually after to is the length of this line segment. In order to calculate that distance, we will consider this right triangle. Do you see that this is a right triangle? So in order to get, so the distance between P1 and P2 should be the hypotenuse of this right triangle. And in order to know the hypotenuse, the length of the hypotenuse, we have to get the measures of these legs. In order to do that, first we label this point as Q. Note that what are the coordinates of Q? Notice that the point Q is in the same plane as P1, where the plane is parallel to the xy plane. This plane is parallel to the xy plane and they both contain P1 and P2. So therefore, these points P1 and Q must have the same z coordinate. That's why they should be z1. Okay? Notice that P2 and Q are on the same plane parallel to the xz plane, sorry. So in this case, it indicates that P2 and Q have the same y coordinate. And what is the x coordinate of Q? Notice that P2 and Q are on the same plane where this plane is parallel to the yz plane. So therefore, P2 and Q must have the same x coordinates. So they should be x sub 2. So as you can see, the only difference between P2 and Q are their z coordinates. Therefore, the length of this line segment should be the absolute value of z1 minus z2. Now, how do we get the length of this line segment? In order to do that, we shall consider this right triangle next. So at this point, you know that this is already z1, z2. This should be, similarly, this should be the difference between their x coordinates, and this should be the difference between their y coordinates. By Pythagorean theorem, this is q, right? By Pythagorean theorem, P1q should be the square root of x1 minus x2 squared plus y1 minus y2 squared. Correct? So, having said that, this is the square root of x1 minus x2 squared, y1 minus y2 squared. Having said that, and given that this is z1 minus z2, again using the Pythagorean theorem one more time, you can get the distance that we need. Example, find the distance between the following pairs of points. So for P1 and P2, applying the distance formula, we have 2 minus 4 squared plus negative 1 minus negative 3 squared plus 5 minus 4 squared. Then take the square root. Notice that the order of the coordinates doesn't matter because we are squaring them anyway. So 2 minus 4 is negative 2, square is 4. Negative 1 minus negative 3 is 2, take the square 4. 5 minus 4 is 1, take the square is 1. The square root of 4 plus 1 is the square root of 9, which is 3. So P1 and P2 are 3 units away from each other. For Q1 and Q2, we will be doing the same. Okay, 7 minus 8 squared is 1. Negative 3 minus 1 squared is 16. Negative 5 minus negative 13 squared, well, that's 8 squared, so 64. Adding all of this together, we get the square root of 81, which is 9. For the midpoint, recall that 2 points in the Cartesian plane with given coordinates, the midpoint is just obtained as follows. We average the x coordinates and we average the y coordinates, and the averages will be the new coordinate of the midpoint. Similarly, for R3, we have the following extended formula. Here, we only have to consider the z coordinates. As an exercise, the midpoint of the line segment joining P and a certain point Q is the point M with coordinates as shown. The question is, what are the coordinates of Q? So to draw the diagram, it is like this is the point P. You see that? With coordinates 1, negative 4, negative 2. And it is connected to some point Q with unknown coordinates. Let's call this X, Y, Z. Now the midpoint between P and Q must be M with coordinates negative 2, 3, negative 6. Okay? So in order to locate or find the coordinates x, y, and z, we shall use the midpoint formula. If we let x, y, z be the coordinates of Q, then we know that the x-coordinate negative 2 of M is the average of the x-coordinates of P and Q. Therefore, 1 plus x divided by 2 must be negative 2. Then solving for x, we get x equals negative 5. Okay? Next, we get negative 4 plus y divided by 2 is 3. Solving for y, we get y equals 10. Finally, we know that negative 2 plus z divided by 2 is negative 6. Solving for the value of z, we should have negative 10. Therefore, the coordinates of the endpoint Q must be negative 5, 10, and minus 10. So let's talk about spheres. A sphere is the three-dimensional counterpart of a circle. Just like a circle, a sphere has a center and has a radius. So a sphere with center C, with coordinates h, k, and l, and radius r, a positive real number, is defined as the set of all points P such that PC is equal to R, or the length of PC must be R. Ito yung mga points sa space that are of fixed distance R from the center C. In the diagram, you shall see that the sphere has a center C and radius R. Notice that the condition that PC equals R implies that equation. The left-hand side of the equation is the product of applying the distance formula for the points P and C. Okay? Taking the square of both sides, we get the following equation. This equation is also known as the center radius form for a sphere, just like the center radius form for a circle in 2D. This is a 3D counterpart. So for example, show that the equation as shown represents a sphere. Identify its center and radius. So to do this, we just have to convert this equation into the center radius form in order to locate the center and radius. In that way, we have shown that this equation represents a sphere. So this should be a familiar technique. So let's rewrite the equation here. Okay, what we do is we group the x terms together. Then we group the y terms together. Sorry, this is wrong. 2y. Then we group the z terms together. Then all the constants will be moved to the other side. Okay? Then what we do is we complete the squares of each expressions inside each parenthesis. So to complete the square of x squared minus 4x, we divide 4 into 2. 4 divided by 2 is 2. Take the square is 4. So we add 4 here. To complete y squared plus 2y, we add 2 divided by 2, 1. So take the square, so we add 1. Okay? Next, to complete the square for z squared plus 8z, we divide 8 by 2, 4, take the square, we add 16. Now take note that this is an equation, so whatever we do on the left hand side must be done on the right hand side. So this is negative 12 plus 4 plus 1 plus 16. Now all in all, we know that this is x minus 2 squared, y plus 1 squared, plus z plus 4 squared. Now simplifying or adding the right hand side, 16 plus 1 plus 4 is 21 minus 12, that's 9. And we know that 9 is 3 squared. So therefore, the equation represents a sphere with center What is the center? The center is 2, -1, -4, and the radius r, which is 3. Okay. Another exercise. Find an equation for a sphere where P and Q are endpoints of a diameter. So, as a picture, this is your sphere. P and Q are diametrically opposite one another. So, for example, kung sphere man ang Earth, kung North Pole yung P, si Q naman ay South Pole. Ganon. So, in order to get the equation of the sphere, we need to locate its center and its diameter. Center and its radius. Okay, so let's see. And R, P, the center and radius of the sphere respectively. Now what do we know? We know that C is the midpoint of the line segment PQ, right? So this should be C. Therefore, the coordinates of C are the average of the coordinates of P and Q. So that's 2 plus 6 divided by 2, 0 plus -4 divided by 2, -3 plus -1 divided by 2, or these are 8 divided by 2 is 4, -4 divided by 2 is -2, -4 divided by 2 is -2. Is this correct? Yes. Now to get the radius, we know that the radius r should be 1/2 the diameter. The diameter is the length of the line segment PQ, which we can obtain from the distance formula. So applying the distance formula for P and Q, we get 2 minus 6 squared, 0 minus -4 squared, then -3 minus -1 squared. Okay, we get the following. 4 plus 4 squared is 16. -3 minus -1 is -2. Take the square is 4. Is that correct? No. The first one should be -4 squared. Correct. So all in all, this is 1/2 the square root of 16 plus 16 plus 4. 32 plus 4 is 36. So the radius should be 1/2 of 6 is 3. Therefore, the equation of the circle x minus 4, kukunin mo yung 4 dito sa center, plus y minus -2, which is y plus 2, z minus -2 is z plus 2 squared, equals 3 squared. So this should be the equation of the sphere in the center radius form. Now let's talk about planes. Recall that in the space R2 or in the Cartesian plane, the equation ax plus by equals c represents a straight line provided that at least one of a or b is non-zero. The three-dimensional counterpart of straight lines in planes are planes in space. So naturally, the graph of the equation ax plus by plus cz equals d, where at least one of a, b, or c is non-zero, is called a plane. Now, first, we need to consider these important cases. Now, in the xy plane, we recall that the z-coordinates of all the points there are all 0 in the xy plane. But if a plane is parallel to the xy plane, let's say it's of directed distance c from the xy plane, the z-coordinates are now constant and are all equal to c. That's why the equation of a plane parallel to the xy plane is of the form z equals c. In the diagram, it is as shown. Parallel sa sahig, sa ground, sa xy plane, yung green plane. Kapag naman yung plane ay parallel sa xz plane, ang kanyang equation ay y equals b. So, in the second picture, ito yung xz plane. So, this plane is parallel to the xz plane. What is true about the points in this plane is that the y-coordinates are fixed. If this passes through 0, b 0, ang equation niya ay y equals b. And lastly, a plane parallel to the yz plane will have equation x equals a, because if a plane is parallel to the yz plane, pare-parehas ang mga x coordinates niyan. And if it passes through a0, 0, then every x coordinate in the plane has x coordinate a. Kung maaalala nyo, sa Cartesian plane, ito yung Cartesian plane, no? Kung yung line ay vertical at dumadaan dito sa a, sa x coordinate, ang equation niya ay x equals a. Kung ang line naman ay horizontal at dumadaan siya dito sa b, ang equation nito ay y equals b. So, parang ito yung natural extensions ng idea na yun. Okay? The equation for a general plane will be discussed later in a full detail. For now, we will just be considering these basic cases. Cylinders. Now, dati, kapag sinabing cylinder, ang nasa isip natin yung cylinder na ganito, no? But actually, this cylinder is just a part of a bigger family. Marami kasi silang pare-pare silang cylinders. Nagkataon lang na ito ay tinatawag nating right circular cylinder. To define, a cylindrical surface in general is a surface that is generated by translating a plane curve parallel to a given line. So, for example, look at the first picture. This is your curve. In this case, circle yata siya. So, pwedeng ellipse yan or what. Ito naman yung line. Ang gagawin mo, yung circle na ito, i-translate mo siya, i-move mo siya, i-slide mo as if it's moving along the direction of the line. Now, this circle will generate a surface. Ito yung surface na yun, no? And dahil circle yung curve na ginamit kong pang-generate, ang tawag dito ay circular cylinder. Sa second picture naman, ang ginamit kong curve na pang-generate looks like a parabola. And if this is the generating line, if I move this parabola along the direction of this line, we can generate the blue surface, also called as a parabolic cylinder. So, depende kung ano yung curve na pinang-generate. Now, if an equation contains only two variables among the variables x, y, and z. Let's say an equation that relates x and y only, pwedeng x and z only, or pwedeng y and z only. Ang graph daw nun ay cylindrical surface. Furthermore, the generating curve on a plane parallel to the coordinate planes of the two variables, and the line of translation is parallel to the axis corresponding to the third variable. Yung third variable, ito yung variable that is unmentioned. So, as an example, if you have an equation that relates x and y only, first, we need to sketch the curve C in the xy plane as usual. Next, we generate the cylindrical surface by translating C parallel to the z-axis because z was not mentioned in the equation. Kapag hindi kasi na-mention yung variable sa equation, ibig sabihin, it can assume any kind of values, unrestricted siya. Kaya natin minumove yung curve along the direction of the z-axis. The cases for the other two instances, yung xz tsaka yung yz are similar. Kapag xz, itra-translate mo naman yung, i-graph mo naman yung curve sa xz plane, i-move mo naman yung curve, generating curve along a line that is parallel to the y-axis. Kapag yz, parallel naman sa x-axis. As an example, if we want to sketch the graph of this equation in R3, so first notice that this equation relates only the variables z and x. So in other words, y is unrestricted. The first step is to sketch the graph of this curve in the in the xz plane. Ano nga bang itsura nito sa xz plane? So parang magpapanggap ka lang na parang xy lang din siya. Si z, palitan nyo muna ng y sa isip nyo. What does that represent? So notice that when we write z equals the square root of 9 minus x minus 1 squared, ang z, nag-a-assume na yan ng non-negative values kasi may square root siya, no? If you take the square, you will see that this simplifies to this, right? And then if I move this right here, you will see that this is the case. What do you see? So in the xy plane, it looks like a circle to me. Meron siyang center na 1, 0. Radius na 3 kasi ang 3 squared ay 9. Pero hindi siya circle. Kasi ang z ay greater than or equal to 0. So, sabihin ito yung upper portion lang ng circle na yun. So, let's try to sketch. So, individually, pag i-consider lang natin yung xz plane, ito yung x, ito yung z. Ang graph na ito ay yung upper semicircle ng circle centered at 1, 0. So this is 1, 0, right? Where's 1, 0? 1, 0 is here. Medyo litan natin. 1, 0 is here. 1, 0 is here. Okay, this is the center. And the radius is 3. So 1, 2, sorry. Mali ako. 1, 0 is not there. Wait lang. Ang 1, 0 ay nandito. At ang radius ay 3. Bibilang ka lang 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So yung circle mo, yung upper semicircle mo should be this one. Oh, sorry. Should be this one. Okay? Okay, to draw the graph in R3, what we do is we sketch the following. So first, idodrawing muna natin yung mga axes natin. Ito yung z-axis. Ang pinakamadali palagi yung z. Ipapakita natin yung positive na side ng x tsaka yung konting negative na side kasi sa xz plane natin gine-generate, right? Let's say ito yung y-axis. Okay na ba? X, y, z. So, nasa na yung circle na ito? Ito yung 1, 2, 3, negative 1, negative 2, right? So our circle, I will use a different color. Centered here. Kulang pa ng isa. 1, 2, 3. 1, 1, 2, 3. So yung circle natin, yung semicircle natin looks like this. Now, using the y-axis, ang gagawin natin, i-translate natin yung curve na ito in the direction of the y-axis. So parang ganito. Okay? So what we do is, what we find is like a kalahati ng circular na cylinder. So parang yung portion na ito sa loob, no, empty. Makakapasok ka dyan sa loob. Okay? So yun yung graph ng z equals the square root of 9 minus x minus 1 squared. Finally, let's now define the trace of a surface. Ano bang isipin ng trace of a surface? Ano lang naman yan? Kapag may trace, may surface, at may plane. So, just imagine that we have a surface S. Let's say this is a surface S in R3. So this is S. And then you have a plane that cuts this surface in some fashion, like this. Imagine mo yung plane. The plane is labeled as big pi. Now, the plane and the surface will intersect in some curve. For example, this is the curve. Yung curve na yan is what we call as the trace on the plane pi. So we just get the intersection. For example, consider the surface S whose equation is z equals x squared plus y squared. So in this case, because it involves the three variables x, y, and z, it may not be a cylinder, right? So we would like to describe and sketch the traces of S in the following given planes. And using the traces, we are going to guess the graph of the surface. So first, in the xz plane, what is the trace of the surface S in the xz plane? First, notice that in the xz plane, y is equal to 0. So if we substitute y equals 0 to the original equation, at the original equation sa substitute nyo, ang may iwanan ay z equals x squared, which we identify as a parabola. So in the xz plane, ganyan yung trace. Okay? How about on the yz plane? On the yz plane, we know that x is equal to 0. So if we substitute x equals 0 in this equation, what we are left with is the equation z equals y squared. And again, in the yz plane, we identify it as a parabola because one variable is quadratic, another variable is linear. So this is your parabola. So the traces in the xz plane and the yz plane are actually alike, right? Let's consider another plane. How about the xy plane? What is the trace? Now in the xy plane, z is equal to 0. So if we substitute z equals 0 to this equation, what we get is the equation x squared plus y squared is equal to 0. Now notice that this equation can only be true if and only if both x and y are 0. That means that the trace in the xy plane is nothing but a point. So in picture, it's like having one yellow dot. right, in the xy plane. So, ang tatamaan daw ng surface sa xy plane ay isang point, right? How about on the plane z equals 1? Ano itsura ng z equals 1? Ang plane na z equals 1 ay parallel sa xy plane, and it is 1 unit above the xy plane. Now, if we substitute z equals 1 to this equation, what we get is this equation, which is a circle, right? It's the unit circle. So, ang itsura niyan, ganito. Okay? How about on the plane z equals -1? Z equals -1 is just a plane that is parallel to the xy plane, but 1 unit below the xy plane. If we do the same technique, we substitute z equals -1, we get this equation. Now notice that this equation is always false. It can never be true because the left-hand side consists of squared quantities and the right-hand side is a -1. So no x and y can ever satisfy this one. That's why there is no trace. In other words, the surface will not pass through the plane z equals -1. So, or we mathematically say that the trace is the empty set, so we do not have a graph, right? So meron tayong mga remarks. In fact, if c is greater than 0, the trace of s on z equals c, ito yung plane na c units above the x-axis, is actually the circle with radius square root of c, centered at the 0, 0. Kung negative naman yung c, ang trace natin ay empty. So meaning to say, the surface will not go below the xy plane. Ang maximum ay nandun siya sa xy plane at tangent siya. Remember, isang point lang yung trace niya sa xy plane. Can you imagine that? Right? Now, putting these pieces together, we have the following conclusion. So, parang ito yung xy axis. Ito yung parabola na trace natin sa xy plane. Inad natin yung parabola na trace natin sa yz plane. Ito yung parabola na yun, right? Ito yung circle na trace mo sa z equals 1, so parang ito yung 1. In fact, yung trace mo sa xy plane, ito yun, isang point. In fact, as you move upward and upward, pataas ng pataas yung value ng c, yung circle mo palaki ng palaki ang radius. Mahuhulaan na ba natin kung ano yung tsura ng graph? Well, upon shading and labeling some important points, ito yung graph ng ating equation. This surface is what we call in the business as a paraboloid. And this is an example of a more general type of surface called as quadric surfaces. Kung dati sa plane meron kayong mga conic sections, sa 3D meron tayong mga quadric surfaces as counterparts. Ang tawag dito ay paraboloid. In the next lesson, we will be talking about quadric surfaces. Paano natin makaklasify ang isang surface gamit yung kanyang equation. Okay? As an exercise, you may want to do the following. Given the plane pi, whose equation is 2x plus y plus 3z equals 6, I want you to sketch the traces of pi on the coordinate planes. What are the coordinate planes? xy, yz, xz. And using these pieces together, I want you to sketch the portion of the graph of the plane that is in the first octant. Okay? See you in the next video.